function f of x is even. That means in Fourier series the bn coefficients are going to be 0. So f of x is going to be dc component plus even harmonics n equals to 1 infinity an cos nx. We have to find out a0 as well as an. Here a0 is going to be 2 by pi 0 to pi f of x dx, which is nothing but 2 pi square by 3 is a0 by 2, so is equals to pi square by 3. This is a0 by 2. a0 by 2 is equals to pi square by 3. Now similarly an is 2 by pi 0 to pi f of x cos nx dx, which is equals to 4 of minus 1 power n square. That is option C is correct. So here pi square sum of Fourier coefficients n equals to 0 to infinite an, which is equals to pi square here. That can be decided by if x square is equals to a0 by 2, that is pi square by 3 plus summation over 4 n equals to 1 to infinite minus 1 power n cos nx by n square. If we substitute x equals to pi square, so this is going to be satisfied. So sum of all Fourier coefficients is equals to pi square, that is option D is correct.
In this question, he has given a three-phase synchronous generator which is delivering a power of 0.9 per unit. Okay, P is equal to 0.9 per unit to an infinite bus at rated voltage. Let us take it as at rated voltage. So Vt is equal to 1 per unit and at power factor of 0.8 lagging. So cos theta is equal to 0.8 lagging. The generator has direct axis reactance as 1 per unit and quadrature axis reactance, that is xq is equal to 0.6 per unit. We have to determine here load angle and excitation voltage EF. Okay, now this type of the type of synchronous generator here is a salient pole synchronous generator. We have two types. You all know that, salient and cylindrical. In cylindrical we have uniform air gap. In salient we have this quadrature axis and direct axis reactances, since air gap is non-uniform. Okay. Now tan delta plus theta is equal to Ia xa plus Vt into sin theta by Vt into cos theta, where Vt represents terminal voltage, Ia armature current, Xa is armature reactance, sin theta, where theta represents power factor angle. Okay. Now what is armature current Ia? We know that P by Vt into cos theta is equal to armature current, where P power is given as 0.9 per unit and Vt terminal voltage is given as 1 per unit, cos theta is 0.8. So the ratio which gives you as 1.125 per unit. Okay. Now tan delta plus theta, where delta is power angle or you can say it as load angle. Okay. Where tan delta plus theta is equal to Ia is 1.125 per unit. Okay, Xa is 0.6 and Vt is 1 per unit. Sin theta is again 0.6 divided by Vt into cos theta, that is 0.8. Okay. Now we will get this one as in radians, convert it into degrees. So 57.894 degrees. Okay. From this we can write this one as delta plus, where theta is cos inverse of 0.8, which gives you around 36.86 degrees. equal to 21.024. This is 57.894 degrees. From this we will get it as delta is 57.894 degrees minus 36.86. So power angle, or we can call it as load angle, which is equal to 21.04 degrees. That is option A. And we have to calculate excitation voltage in per unit. Now, what is excitation voltage here? Excitation voltage, or you can say it as generator EMF. Okay, EF is equal to Vt into cos delta plus Id into Xt. Okay, now what is Id here? Direct axis current, which is given as Ia times of sine delta plus theta. Okay, so Ia is, we know that it 1.125 into sine delta plus theta, angle is 57.894. Okay, which is equal to 0.953 per unit. Now substitute here, Vt value is 1, cos delta is cos 21.024, Ia is 1.125, we got Id as 0.953, direct axis reactance Xd is equal to 1 per unit. We will get it as excitation voltage, or you can say it as generated EMF EF is equal to 1.8864 per unit. So option is